Okay, hi everyone. Sorry for the delay. My name's Lewis Rockcliffe. I work with Jonathan at the Australian Antarctic Data Centre. I'm a sort of software developer by trade, but these days I can sort of consider myself to be a bit more of a data plumber. I move lots of the various different data around between various systems. Um, and so one of the things that seems to be quite a common topic, and it's definitely a growing area of interest, is getting data back from remote systems over satellite links. And that's certainly, over the last couple of years that I've been at the AAP, there's certainly been a lot more that have been going in that kind of area. And for those that are in the know, like transmitting things over satellites is never as smooth as you would hope. They're intermittent, they have high latency. Obviously, future technologies is hopefully going to improve this somewhat, but I imagine that the challenges of data transfer is still going to remain. So as you can see from my overview, what I'm going to do is I'll take you through a few of the different applications that we've got first, sort of what are we doing, and roughly sort of what they are and how they work. And then I'd like to get a little bit technical and talk about sort of the couple of the technology choices that we've done and sort of why they work, because I think they might not necessarily be on your radar as options, but I'll go into details about why they actually work pretty well for this purpose. Anyway, so starting off, one of the first things that I did when I sort of came to the AAD was to look at how we do our sort of weather stations that we have on our various different Antarctic bases. The existing system was kind of old. It was sort of written in C by a previous employee that didn't really work there anymore, and it was entirely custom built. It worked quite well, in fairness, but sometimes you need to bring things into the modern century, and so we took a look at it. The high level stuff here is that the weather stations themselves are operated by our Bureau of Meteorology, so we're a little bit hands off in that regard. But where we get involved in is data transfer. So the types of data that we're talking about here is sort of minute average sensor data. So just your standard sort of atmospheric sort of measurements. And the main thing that we use for this is a product called Fluent D. It's sort of open source. It's a bit of a Swiss Army knife, I find, for moving data from one format to another format to across systems. Has my slide changed, or is that still kind of static?
Still on the weather stations.
Okay, all right, you can see that. Cool. All right, excellent. Okay, so yeah, so I'll definitely talk a bit more about Fluent D later on in the talk. It's definitely an interesting kind of thing, but not necessarily exclusively designed for this type of application. Next up was our Nuyina webcams. This is something that we installed pretty much from day zero. We got a requirement from our media team that they wanted to basically televise the delivery of Nuyina from the Netherlands to Hobart, and so we hadn't even set on board yet. We had no systems in place. We had lots of plans, but we didn't really have anything in place. And so, yeah, we wanted something fairly compact. And so what the team came up with was actually writing some software to run directly onto the access cameras themselves. So the idea is that we would install them, plug them in, power them, and they should hopefully come up and work. And work they did. They worked quite well. So yeah, so in terms of data, we're talking like a still image every minute. And the main sort of connectivity technology that we use for that is S3, which is something that the Australian Antarctic Data Centre uses a lot for a lot of things. And I'll get into that a little bit later around sort of why that works. Another wonderful tortured acronym is our ARTEMIS system. Now, this is not to be confused with the NASA moon mission. Yeah, as you can see it from the top there, it's an autonomous remote environment monitoring system. But basically, it's a sensor platform. We could put anything we want on there, and the technology team at the AAD has done a really good job at making a nice little package designed to be sort of dropped from an helicopter just in place with a nice big wide base so that hopefully it doesn't need guy ropes or tie downs or anything like that. So we might be able to put it into some of the Antarctic specialty protected areas. And we have plans to send one to Heard Island. In terms of like the equipment involved, yeah, we've got a PTZ camera, we've got a weather station on board. It's connected through a BGAN satellite, as well as having a sort of Campbell Scientific data logger and a little BeagleBone Black that really is doing a lot of work for such a cool little board. Now, for this, one of the main things that we wanted was this to be cloud enabled, and so we actually don't connect this to our home base in Kingston. We connect this up to the Amazon cloud using their IoT suite, which has some pretty neat features, as well as using S3 to transmit all of the imagery back. So yeah. Power requirements on this have been engineered quite well, and so these things have been down on the ice for about a year now, and they go dark a bit through winter because it's all sort of solar backed, and we turn everything off to sort of conserve power. But so far we're getting sort of minute average sensor data and hourly imagery. And we can control these things remotely. Like we can tell the PTZ camera where to point and how far to zoom in, and all that kind of stuff. So that's like it's a pretty neat installation. Next up, we'll talk about the RSV Nuyina. Now, as the previous talk sort of went into, there's a lot involved in running one of these things. Yeah, and that's fortunately for me, sort of where I come in is after a lot of that hard work is actually being done, I get a CSV, which is way easier than dealing with instruments and lots of big databases and all that kind of stuff. So, big props to the team on board for getting a lot of that set up. And it's still early days for the Nuyina. It's she's just down there doing ice trials for the first time now. So we're a little bit further behind the BAS team. But yeah, so in terms of our underway data, so far we've got the suite of atmospheric sensors hooked up. We've got some echo sounders, as well as our ocean pack system, which is our sort of uncontaminated seawater line with a whole bunch of sensors on that to measure some salinity and PCO2 and phytoplankton and some other things in there. That's pretty cool. We've also got an ice wave radar that sort of counts the waves. It's kind of it's a bit of a neat instrument that sort of gives us an indication of how rough the sea is and what's going on there, as well as, of course, position and navigation information. To give us context for all of those measurements so that we know where the ship is and its pitch and roll and draft. So yeah, the team's done a great job to not only get all of that, all of those sensors commissioned, but aligned and all in a nice, easy to, for me, easy to process format. And so what happens is it gets sent from the ship back to Kingston to our S3 service, and from there I've got events that read that into a database and present it straight out to the world to our GeoServer layer. So you can see that right now, like that's happening all the time. It's a very hands-off process, which is nice. And yeah, it's our sort of 1 minute time aligned underway merger. Sort of the main clients for that is our Bureau of Meteorology, but we've got people all around the world sort of looking at this. Okay, so like I said before, I want to sort of get a little bit technical, and so one of the things that I want to talk about is our use of sort of Fluentd and sort of what it is and how it works. So it's an open source product. It's a Apache 2 license. It's mainly designed around sort of enterprise log aggregation. So it's not necessarily like a data system or a data science system, I should say. It's mainly designed for sort of server or cloud-based systems where maybe you've got lots of different microservices that are all spewing logs, and you want to aggregate them in some way. But what it really is fundamentally is it's a modular stream processor. And so by that, it's got like a whole bunch of different modules that you can chain together in however, whatever mechanism you want in order to solve your problem. And that makes it extremely flexible. It's built to be scalable and fault tolerant. It's loads of community plugins, and you can write your own plugins if that's what you need to. It's got built-in support for Grafana and Prometheus, and so that makes it super easy to actually see what's going on. And that's one of the things that I find that lacks with a lot of sort of custom systems is that visibility of that, the ability for someone to come in and actually look at it and go, right, this is what's going on. Is it working? Is it not working? That kind of thing. And so as you can sort of see, a general pipeline there, you might have a bunch of inputs in terms of the Antarctic weather station stuff, like we're reading from UDP streams on station into a Fluentd, and then you can sort of do filtering based on regex. You can do standard parsing, like if the message is already in a standard format, like a JSON packet or a CSV or something like that, then there's built-in parsers to do that. And then you can look at translating the message, and so we use a lot of sort of regex parsers to take the sort of UDP messages and translate that into something that the downstream can handle a bit more. The biggest part of it that's probably helped us to transmit things over lossy satellite connections is the fact that it's got built-in buffering. And so that's extremely reliable. Like we've got, not only do we have buffers down on station, we also have like a buffer writing into the database in Kingston. So we've got sort of both ends able to, it can detect whether things are actually writing or not, and buffer it locally and just automatically recover. Which is excellent, not just for satellite links, but if you want to do database maintenance or you want to take down your database server for a time, we don't even need to think about this. It just recovers, and we keep an eye on it to make sure it does. But and this has been running for about 2 years, and it's a very, very reliable thing. So yeah, may not be on your radar, but definitely worth checking out, I think. The next thing that I want to talk about is Amazon S3. Now, normally when you think about S3, you think about, oh, okay, I want to store some files in the cloud. I want it to be cheap. What I want to talk about is actually the protocol, because it does some clever things that makes it kind of almost ideal for transmitting things over large distances, which in a sense is what it was designed for when you talk about transmitting things to the cloud. But yeah, so fundamentally it's HTTP based. So that's awesome because it means that you can go nuts with proxies. It plays nice with corporate firewalls. You automatically, you get sort of HTTPS and TLS if security is a concern. Yeah, it's pretty nice to deal with. The next part is the authentication is it's non-interactive signature based, and what that means is when you're crafting something to send to a server, it's entirely like on your own. You create a valid packet and you send it out into the world. You don't have to create a session with a server. You don't have to log in. There's no backwards and forwards, which makes it really awesome for high latency connections. There's not a lot of back and forth between you and the server. It's actually quite easy to do remote file comparisons. So if you've got a set of files in your server and you've got a whole bunch locally, and you want to make sure that you know where you got up to, you can actually do that with a single request. And that request will return you back really basic information. Just the file name, the file size, the last modified, and the E tag, which is actually the 5 hash. And all of that just means that you can quite easily and quickly determine what's on your server and sort of where you're up to and whether your local files have changed or not. A big part of it that I think really, really helps is when you upload something to an S3 server, you can add the content MD5 and content length headers into the request. And the server will verify these, and it won't actually accept the file and insert it into your file system if those things don't match up. And that's partially, I think they designed it around that for their security model, but it means that if your transmit bails out halfway through because the satellite's gone on, then there's nothing to clean up. The system just doesn't accept it. And so from a data integrity perspective, like it's pretty much perfect. And a big thing that sort of follows on is we make use of the bucket notifications. And so most S3 implementations have an ability to send a webhook to like another server to say, hey, I've just received a file, here it is, which makes downstream processing very easy. Like you don't have to have a polling timer or anything like that. It just sends an event, which you can then go, oh, I've got a new CSV. And then the downstream processing is super simple to read that into a database or refresh an index or whatever you want to do. For our ARTEMIS system, we use sort of Amazon IoT, which is a pretty comprehensive offering from Amazon. It's fundamentally an MQTT system, basically, with certificate authentication, which is a fairly lightweight sort of IoT protocol. It's in pretty wide use around the world. There's loads of different open source implementations of it. Yeah, so there's and on the Amazon side of things, it does very well of hooking into different events, so that once messages come in from remote, you can trigger certain actions depending on what you want to do, whether you want to transfer them, put them into a database, store them to S3, or all of the above. One of the most probably useful things that we're sort of using for it is that it's got an SSH bouncer built into it that's really cheap. So the satellite provider that we're using, it costs quite a lot to actually have the end device not being through a NAT, sort of network address translation. And so that means that the device needs to kind of have the ability to dial out and connect to something. And we didn't really want to give the ARTEMIS installations the ability to dial straight back into our Kingston headquarters. And so we realized that we can do this quite easily with the Amazon IoT platform, where you can click a button on your sort of cloud dashboard. It'll send an MQTT request out to the device, and it will then it gets given some credentials and an endpoint, and then it dials back to the cloud in an SSH fashion, which we can then dial in from our side and get full end-to-end connectivity. And so we've done full remote operating system upgrades. We've done troubleshooting. like all those kinds of things that you need to do when you've got something out in the field, and it actually works really well. So yeah, definitely recommend that one.
1 minute, Lewis.
All right, well, good thing that I've just about done then. So yeah, that's all I've sort of had to say. We may or may not have time for questions, but yeah, I hope you're having a good Polar Data Forum 5.
Well, thank you very much. Probably going to cut off the questions, I'm afraid, but if you do have some, you can send them to Lewis or to me, whichever is easier, and we'll try to make sure that he gets back to you. All right, thank you very much, Lewis.
All right, no worries.